3.1 is the frequency tables and relative frequency table and bar graphs. After we collect information from each individual object we study, which is all the samples that we did last chapter, we have a list of raw data. To make sense of the data and to look for patterns, we need to organize it with tables and graphs. For qualitative data, we typically start organizing data by counting how many objects were in each category and then computing the proportion percentage of objects in each category. Categorical variables or qualitative variable, that's another word, consistence of names or labels of group or individual. Please write that down. And the examples for that is favorite movie genre, action, comedy, drama, suspense, horror, all those kind of things. That is a category. Second one, numerical variables is called quantitative. And when you have quantitative, it's consistent of measurable quantities that describe individual. For example, movie theater closest to you charge movie ticket price. Measurable quantities $9.50, $10.50, or $11. Or for example, your height, your weight, all those kind of things is something you can measure. That is numerical. That's quantitative with the N. I want you guys to pause it for a minute and answer the question. Here are the answers. Number 1 is quantitative numerical. Number 2 is qualitative categorical. Number 3 is quantitative numerical. Number 4 is qualitative categorical. Number 5 is qualitative categorical. Going on to the next, make sure you write down all the things that's read. Just a quick reminder, just in case you forget. All variables are either categorical or numerical. It's one or the other. You cannot be in both. Describing what we're going to do. Definition of frequency distribution. Another word is just frequency. Frequency is a lists each category of data and the number of each category of data. So we're going to list qualitative, then we're gonna figure out how many times that qualitative happened. And that's what we're gonna use, a frequency table. And a frequency table is a table that lists all the categories and their frequency. So what are the qualitative and how many times those qualitative happens. And I will show you an example in a couple minutes. You're just getting down the definitions. Going on, what's the definition of relative frequency? In a smaller requirement, we're going to call it relative frequency. And relative frequency is how often that occurrence happen or how often the category happen over the total number of observations of the whole thing. And it's a proportion. It's going to be a fraction. Please add that on. And we can write it in decimal. And so relative frequency table is a table that lists all the categories and their relative frequency, which is in this case, it could be fractions, could be decimal. And then because we are graphing, we are going to use the decimal. So you need to make sure that when you set up your table, you know how to find the frequency of the category. That means be able to put it in fraction and put it in decimal. That should be data. The first question says, what was the population? Pause the video if you don't want to hear the answer. Let me know if you have any question for letter A through G. So now what we're going to do is we are going to put them in something that's called a relative frequency table. Hopefully it's very simple. If I do a couple examples, you will understand what to do. So what happened here is you are going to take a look at the different blood type. And blood type in this case, you have A, B, A, B, O. What you're going to do is you're going to have mark in how many times does it happen. Go ahead and do that. I'm going to pause it right now. We're now going to mark our frequency in. So you have 1A, 1B, 2B, 1AB, 3O, and you have another B, and so forth. Please mark your categories with how many those letters shows up. Those are called the frequency. Please mark in your frequency column how often each blood type shows up. A once, B twice, AB once, 3 O's, and then you have B again, and then you have AB, and then you have 3 B's. So I'm going to do 1, 2, 3. I like to mark my by 5s, just make it easier for me to count. The next one is going to be A again, and then O, and then you have A again, and then you have O, 3 more O's. This is 1, 2, 3. Then you have AB and AB, and then you have another A, and you have a O, and then you have another B, and you have A. So now I'm going to double check, is that all of them? Because it says 24, so it's 5, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I have all the Army inductee counted for. Now moving on to the next column. The next column says relative frequency, and it says it's a fraction. So if you go back and look at your definition of relative frequency of the category, that means how many times does A or B shows up in each categories over the total number of observation, and then total number of observation is 24. So that's all we have to do. We're just going to write down, you have 5 people has blood type A over 24. Then you have 7 over 24. Then you have 4 over 24. And you have 8 over 24. Do I need to simplify? So this is going to be 1 over 6, and this is going to be 1 over 3. And after that is you're going to put them in the calculator. So I am going to pause it, get your calculator and work it out, and you guys can check the answer. We plot or we graph only using decimal, not fractions. Answer H, I, and J. So what should the frequency column add up to? 24, because that's counting all of them. What are the relative frequency as fractions? 5 over 24, 7 over 24, and 1 over 6. Or you can put down 4 over 24, and that's 1 over 6. Or A over 24, that's 1/3. And then the next question is, what should the sum of relative frequency in fraction form always be? And I just proved it to you, because all the different parts has to add together how many people was taking the test or giving the survey or taking the data. It's 24 over 20, because we are talking about the sum. What are the relative frequency as decimal fraction round out to the nearest thousands? And then you don't even have to. You can just look at it when we did the calculation. That's really just 1 from the decimal. The next question, why is the sum of relative frequency as decimal fraction not always exactly 1? Well, the reason for that is because rounding. We are just lucky and then we chopped off at the right place. But the rounding sometimes will throw your numbers out. And the way to make the less error in rounding is to carry the decimal further out. Based on the data, what was the most common blood type? Go up there and take a look. Who has the most count? Who has the biggest fraction? Who has the biggest decimal? So in this case, if you look at it, if you look at the frequency, it will be 8, type O. Relative frequency, biggest fraction, which is A over 24. That gives you 1/3. And then looking at the decimal, that will be 0.333. So because of that, you have the most common blood type, which is going to be O. Least common type is going to be AB. Letter N. Why is this information needed for the military? I would think because in a situation in war or in any cases a person gets hurt, they will have blood available for transfusion or anything like that. So just going to write it down in case there will be blood available. To construct a frequency bar graph, and then to construct a frequency bar graph, down the definition of bar graph, because there's certain things I expect to see. There's not really a definition, it's just a courtesy of when you're putting a bar graph together, you are going to take a look the information that's given it to you. And I'm pretty sure when you take your ACT and SAT, when you prep something, your teacher will tell you about it. You are going to have the categories of qualitative variables are placed on either the vertical or horizontal axis, frequency or relative frequency on the other axis. So personally, I like to put the category on the bottom and the frequency goes on top. So this is the category, and then I will have my frequency on the side. Relative frequency there, okay? Second, rectangles of equal width are drawn for each category where the height corresponding to their class frequency means how many, or relative frequency, the decimal. So your bar, when you draw it has to be the same size, or at least close to it, okay? 3, there are gaps between them. And the reason the gaps is being mentioned here is because we're gonna have graphs that does not have gaps. So you need to be careful. So there are gaps for drawing a frequency bar graph or a relative frequency bar graph. Next thing, a special type of a bar graph is called a Pareto chart. Is a bar graph whose bars are drawn from tallest to the shortest, and we are not going to do that. The last thing, bars identify frequency of a categories. When you collect data for a qualitative question where each object can belong to exactly one category, you cannot have blood type A and also have blood type AB. That's just not going to work. Let's go back to construct a frequency bar graph. To construct a frequency bar graph, I'm gonna say this is my A, and I'm gonna have space. This is my B, and this is AB, and this is going to be my O. Now, right here, I'm gonna mark it. I have the highest number is 8. 1, 2, 3, 4, 5, 6, 7, 8. Grab my data, and my first data for A, I have 5. And I usually like to mark like every 2, so it's not so crowded. So the 5 is 1, 2, 3, 4, 5 right here. So that's 5. And I like to put it in so I know which one I'm talking about like that. You don't have to sit there and color. And the next one is B, and B I have 7. So you need to go up to 7. That's about 7. The next one is AB. AB we have 4. So 1, 2, 3, 4. And the last one is O, and O we have 8. There. And on the bottom, I usually like to put a label on it, and that's gonna be blood type. And on the side, I would like to put down as my frequency. That is how you construct a frequency bar graph. The next one is construct a relative frequency bar graph. And before we do that, we are going to put a x-axis title, and that on the bottom is going to be the same thing. I like to put blood type right here. On the side is going to be relative frequency. What we're going to do is we recognize number we used before. The highest decimal is about 0.33. Because of that, I'm gonna go as high as 0.4. Right here is gonna be 0.4, and I'm gonna do halfway. It's gonna be 0.2, and then cut them in half. That's gonna be 0.1 and 0.3 right here. Now the reason I do that is because I want the graph to be as big as I can get, so it's much easier to see. I have blood type A, B, and AB, and O. A is going to be about right here, 0.208. So it's just a little bit over 0.2. So I'm going to draw the line down, make a rectangle shape, and then color in. I usually like to label on top because sometimes we will ask you to answer a question. So that's a 0.208. And I'm going to label the bottom. That's the A. Now the B is going to be about 0.29. So it's close to 3, but not quite passing 3. About the same width. It's 0.292, and I'm gonna say that is B. And another one is AB, and AB is only 0.16, and 0.16 is about halfway between 0.2 and 0.1. So I'm gonna say, okay, it's about maybe right here, 0.167. I think the space is a little bit further. And then the last one is gonna be 0.333. So that's O. So it's a little bit more than like a third way. Don't forget to label your AB, and then don't forget to label your O. And so that is how you do a blood type related to relative frequency bar graph. We need to read through one more thing. We're gonna have you guys answer some questions. We will not ask you to do a graph because it's really hard to make sure all the circles and pieces come out. But we're gonna do that on a Google spreadsheet. Okay. So on the definition, circle graph is a pie chart. Sometimes we call it. The categories of the qualitative variables are represented by sector of circle, which is a slice of pie, which is a percentage, where each sector or slice is a proportion to a relative frequency. In this case, finding the fractions and finding the decimal and changing into a percentage for the category. Let me say it one more time. Finding the fractions, finding the decimal, and finally finding the percentage. 2. To make a pie chart, you need to get the size of each angle. That's why it's kind of difficult. 3. Find what parts of entire circle should represent each category. 4. Use relative frequency times 360. And the reason to do relative frequency, now think about it, relative frequency is the decimal. So when they say times 100, that means they are turning it into percentage. So this is actually a percentage. Last one. The slices of a circle are proportional to the relative frequency. Okay, they are the same size. They are talking about the same thing. Last two things. Distribution of a variable. A table, a graph, or a formula that tells us what value of a variable can occur and how often. So in this case, kind of like a frequency. Any other things we talk about how often certain things happen. Sum of relative frequency, categorical variables. The sum of relative frequency, all the categories equal to 1. So few last questions. Find the proportion of observation that fall in the A blood type category. What does it mean in this situation? Well, it's just saying you have find the proportion of the observation that fell in the A blood type category. That means if you have an A right here, that is going to be how many people? That's going to be 5. Talk about find the proportion of the observations A fall in the A blood type category. What does it mean in this situation? Well, it means that if you remember from before, 5 out of 24 inductees have A blood type, and this is about 0.208, and if you switch it over, it's about 20.8%. And because of that, you should be able to conclude also that this means 20.8% of the Army inductees has type A blood. So that's about 20.8% of all the Army people that comes in that have type A blood. So in this case, the helpful thing is if their situation arises, they need to make sure there is enough blood to supply to everybody who might be in trouble. One of the things they want to take into consideration. Next question, B. How about do not? The inductee does not fall into the type A category. So the way we talked about before is if you have it or you have not. And so if you have a not, you take the whole thing minus the ones that I already have. So in this case, the whole thing is considered to be 1. 1 minus 5 over 24. And if you do your math, that means taking 1, write it as 24 over 24. So if you can do that in your head, common denominator 4, and then we spend time to talk about it, that's really 19 over 24. And that is about 0.792 or about 79.2% of the people who does not have type A blood. That's all. And so we can write that down just in case. That will conclude our notes in section 3.1. And don't worry about number letter C and D. Thank you so much, guys.